Hi, this is Yosef Bharti, and we are here at KubeCon Cloud Native Con in Atlanta, and we have with us once again in person Kolton Andrus, CEO of Gremlin. Kolton, it's great to have you on the show.
Thanks for having me again.
This is the first time you and I are talking in person. We have spoken, remotely so many times. So it's great to see you in person. We are here at KubeCon. Did you folks make any announcement here?
We did. We're excited to announce a partnership and an integration with Dynatrace, making it easy for people to have insight into their Kubernetes clusters, making it really easy to set them up within Gremlin, so that people can one click pull their apps down from Dynatrace, set it up in Gremlin, have the monitoring automatically wired up, and be ready to start running tests and getting value out the gate.
That was an excellent elevator, but let's just expand it a bit. That how does it really impact Kubernetes users?
Well, I think one of the things we see when it comes to failure testing is people have to do this kind of setup work before they get to the meat. They got to go model their services in Gremlin. They got to monitor their services in their monitoring tool like Dynatrace. There's a lot of moving pieces, and they got to have the right alerts and monitors in place. Do you have an alert for error rate? Do you have an alert for latency? Do you have an alert for throughput? Sometimes engineers don't have that. Sometimes they don't have it in a staging environment. What's great is Dynatrace comes out of the box with a lot of these metrics. And so by partnering with them, we were able to integrate in a way that we just pull those metrics in, and we have those alerts in Gremlin without any setup required from the user. So that's what allows them to skip all of this kind of preamble stuff and get to running the test and knowing whether their system passes or not.
Excellent. Thank you. Now let's just step back from this announcement partnership and talk about chaos engineering a bit. Can you talk about the state of chaos engineering in this age of AI, and also is it less important or is it more important?
Yeah, well, that's a layup because we're generating a bunch of code that we don't necessarily know what it does. We're generating code at a faster rate, and that's the goal. The goal is velocity and move quickly, but with that comes complexity. And if you don't understand how the system behaves, you're going to be surprised in a nasty way. So I think chaos engineering and reliability testing really allow us to go mitigate that work. It's like a set of, you have an AI application, treat it like a black box. Now we're going to go say, here's what our reliability bar is. We're going to go test it. Is it redundant? Does it scale? Does it handle a piece of it failing? What happens when a dependency fails? And if the engineer didn't specify, AI, think about these concerns, they probably didn't handle them, which means they're probably at risk to those issues. So I think that ability to really go prove that out, help people understand that risk, and ideally help them fix it, is what's going to help us continue to keep that velocity in AI without sacrificing quality.
Excellent. Thank you. Here at KubeCon, I don't know the reason, but all I'm hearing about is AI SRE. Okay, it seems like there is a lot of hype. There has always been, when the Docker was there, a lot of hype was there. When Kubernetes came out, there was a lot of hype there. So there is a lot of hype. From your perspective, how realistically AI can really manage complex real-time systems at a scale?
I don't think we're anywhere close. I'm going to just throw that contrarian point up front. There's a couple reasons for that. One, our great SREs and operations folks have been training their own wetware, their own models for 20 years. And that ability to quickly have a sense of the system, the history, the context, and know what went wrong is going to be very hard to replace. It's going to require a lot of data and a lot of experience. I think the other thing that's lacking is the responsibility when it comes to AI. When you are in the middle of a production outage, I was a call leader at Amazon, if you are empowered to make that judgment call that could make everything better or could make everything worse, that's a high stress, high judgment call you have to make on the fly. I think it's going to be quite some time before AI builds the trust that people are going to allow it to make these big, large changes in production. And if they can't make those changes, they're just not going to be able to resolve and do the kind of things that we're doing today. So I think there's a lot of basic, easy stuff that is fine. And automate the toil away, that's nothing new. We love that. But when it comes to dissecting and triaging a complex distributed system on the fly and coming up with a fast response. I mean, internet's, the issues out, Your customers are mad. Every minute counts. You don't have 3 minutes to wait for an AI to think and come back with maybe the right answer and maybe not the right answer.
And I mean, we see failures happen, and the whole world goes down, when those failures happen.
It's been a rough month. We've had two major cloud provider outages.
Given the growing adoption of AI and automation, what is the direct impact on practicing chaos engineering? Is it getting harder and harder to convince teams, hey, you should have these practices in place, or is it getting easier?
I don't know that it's harder or easier at this point because it's still fairly new for a lot of teams. I think as teams start to feel the pain more of that increased velocity and probably the increased issues or complexity that comes with it, I think that's where it's going to allow, it's going to remind people the importance of it. It's a safety net. This is what good regression tests are, is, hey, I expect the system to operate this way, whether that's through failures or through a customer behavior. And if AI is out there writing code, we want to make sure it's doing the right thing. So I think chaos engineering reliability will be the checks and balances around AI SRE and around just AI systems as a whole.
Before I wrap it up, anything else that you would like to talk about, either the Dynatrace partnership or anything else in chaos engineering space?
The other thing that we talked about last time is just our reliability intelligence. So as much as I'm skeptical that AI will just solve all my problems, we are leveraging, machine learning and AI to help our customers do a better job. And one of the things we believe at Gremlin is make it easy to do the right thing, make it fast and right and credible. And so our reliability intelligence, people run a test with the monitoring integrations like the Dynatrace one, we're able to give them an answer. Yes, your system performed as expected, or no, it didn't. The last step is if it didn't, you still need to go fix it. And so we put a lot of thought and effort into providing real credible, actionable advice on how to go fix the system.
If I ask you, how do you see chaos engineering is going to evolve with this, reliability remediation work is done with the help from AI? Now we can say AI is augmenting humans, or humans or experience is augmenting AI, but how do you see chaos engineering will evolve?
I think chaos engineering is almost evolving tangentially. Like, you need the chaos engineering regardless of whether it's people or AI. It's still code, it's still machines. The same 10 things can go wrong. You need to practice those. So I think the biggest way that chaos engineering is growing up is chaos engineering needs to be more like security. A lot of companies do what I call field of dreams DevOps. If you build it, they will come. We'll build this great tooling and we'll just trust that all the engineers will devote their free time to come and embracing that tooling to build better software. But the truth is, the organization needs to incentivize that. It needs to reward that. It needs to hold people accountable. And so that's what I've seen over the last 3 to 4 years. The most successful companies, they want a standard of reliability, a standard of quality, and they want to ask every team to do that, meet that bar. And so that's how I've really seen chaos engineering grow up from one-off projects and experimentation into a systematic approach to improving the reliability of a company or a system.
Kolton, once again, thank you so much for joining me. Of course, talk about your partnership and also the whole evolution of chaos engineering. Thank you so much, and I look forward to chatting with you again.
It's a pleasure. Thank you.
Thank you.